In section 7.6, which is the last section in chapter 7, we're going to talk about dilations and similarity in the coordinate plane. Now, we've already talked about dilations, and now we're going to relate it to similarity in chapter 7. Now, as you remember, a dilation is a transformation that changes the size of the figure but not its shape. So you don't need to write this problem down. I'm just going to quickly go over dilation in example 1. So here we have a figure that shows the position of a JPEG photo. Draw the border of the photo after dilation with a scale factor of 3/2. So as you can see, we have 4 points here, A, B, C, D. Those points are 0, 0, 0, 4, and so on. If you multiply all of the coordinates by 3/2, you get A prime, B prime, C prime, and D prime, which are shown in this picture below. If you plot those points, you will notice that both these shapes are similar. In example 2, it says that we have to find the coordinates of similar triangles. Now, given that triangle, AOB, the small one here, is similar to triangle COD, you need to find the coordinates of D and the scale factor. So we can use a proportion. We don't use the zeros because that doesn't help us, but we can write a proportion as, for example, 2/4 right here equals 3 over x. Obviously, we can see that x is 6. Therefore, the length of OD is 6, which gives us D, the point, as the ordered pair 6, 0. Now, we also have to find the scale factor. So how do you go from 3, 0 to 6, 0? You multiply by 2. So the scale factor is 2. In example 3, while this looks easy, we are going to have to use what we know about similarity theorems to prove that the two triangles are similar. Now, the given are these 5 ordered pairs, A, B, C, D, and E. Now, they're actually not going to be graphed for you, but I've already put the graph here. We want to prove that triangle ABC is similar to triangle ADE. Well, in order to prove they're similar, we can use different things, such as side, side, side. We could use side, angle, side. So let's start off by finding the length of AB and the length of AD. Since both those sides are corresponding, right here, we can see if their ratios are equal. So let's find the distance of AB. So A, if we subtract I'm using the ones here, so 1 and -1, that gives me 1 minus -1, which is 2 squared, plus 5 minus 3, which is 2 squared. That gives me 4 plus 4, which is the square root of 8, which gives me 2 root 2. If I find the length of AD, if I subtract my x values here, that's 1 minus -3, so that's 4 squared, that's 16, plus 5 minus 1, which is 4 squared, which is also 16. That gives me 32, which then gives me 4 root 2. Now, the similarity ratio, if I divided AB divided by AD, the length of AB divided by AD, that gives me 2 root 2 divided by 4 root 2, which gives me a ratio of 1/2. Now, let's find the length of AC and the length of AE. So AC, 1 minus 3, so that's subtracting my x's, 1 minus 3. That gives me -2 squared, which is 4. And then I subtract 5 minus 4, which is 1 squared, which is 1. That gives me the square root of 5. AE would give me 1 minus 5. 1 minus 5. That's -4 squared, which is 16. And 5 minus 3, which is 2. 2 squared is 4. So that gives me the square root of 20. If If I simplify that, I would get 2 root 5. And now we have to follow the same format. So AC, the length of AC divided by the length of AE. And that would give me the root 5 divided by 2 root 5. That would also give me 1/2. Now you could follow this exact same pattern and find the third side ratios. But since we know that they share a common angle, which is angle A, we know angle A is congruent to itself because of reflexive property. And therefore, these two triangles are similar because of side angle side similarity. In example 4, we have to use the side similarity theorem. So graph the image of triangle ABC after a dilation with a scale factor of 2. Verify that triangle A', B', C' is similar to triangle ABC. Now you will be given the blue triangle. Now if we multiply everything by 2, which I'm not going to show that work, that's easy. If we multiply everything by 2, you get the red triangle, which is A', B', C'. We want to verify that they are similar. Now here we can follow the same rules, but we can't use side angle side because there are no angles that are shared. So what we have to do is use side. So we have to find the lengths of all 3 sides of both triangles. I'm just going to go ahead and tell you what they are because you can find the distance on your own. So A', B', if you simplify it, would be 4 root 2. A', C', the length would be 2 root 10. And the length of B', C' would be 2 root 10 as well. The length of AB would be 2 root 2. The length of AC would be root 10. And the length of BC would be root 10 as well. Now, if we find the ratio, and let's say we divide each of these. So we could take 4 root 2, which is right here, the length of the length of A', B', divided by the length of AB. That would give us 2. And then we could take 2 root 10 divided by root 10, which is the same on both of these. And that would also be 2. So we know the ratios of all 3 sides are all the same. Therefore, we can say side, similarity. These triangles are similar.